Welcome back to all the students. If you recall, in the previous class, we had looked at what is a progressive wave, what are the parameters of a progressive wave, and how to write the equation of a progressive wave. And we saw that the various parameters of progressive waves were amplitude, frequency, wavelength, wave vector, and phase. These were the various parameters of a progressive wave. Now, in a medium like a surface of water or air or any such medium in which waves can propagate, it means I'm basically speaking of only mechanical waves. But what we are studying for mechanical waves, we will later on see is true for non-mechanical waves also. But let us limit our discussion to mechanical waves for the present. So when any wave is propagating in a medium, then the medium is disturbed only by that wave. For example, here is wave 1, which you can see is propagating, as you see on the screen, from left-hand side to right-hand side. So every particle in the medium is being periodically disturbed only by this wave 1. Okay, then in the same medium, if we have another wave 2 that is going in the opposite direction like this, I have deliberately given it a different color so that you will later on be able to distinguish between the two waves. So wave 2 is represented by brown color and it is propagating towards left hand side. Wave 1 is represented by blue color and it is propagating towards right hand side. You see both these waves propagating in the same medium and in opposite directions. Few things that you will notice immediately about these waves is that they are of same wavelength or of same frequency. Like I will just let them move and I will pause them here. Now you see they are just superimposing each other. Same wavelength, same frequency, same amplitude also. You see that this is going up to the first blue dotted line, the blue reference line, and below the reference axis also it is going up to the blue line. So both the waves are of same amplitude. And suppose they are propagating, then how will the resultant wave look like? The resultant wave will look like this. You see that red wave? And if you observe that for a few moments, you will realize why the red wave is called as a stationary wave. I will remove wave 1, remove it from our view, and I will hide wave 2 also. Now just observe the wave given by this red line. Does it look like it is moving towards left hand side or towards right hand side? No, right? It just remains where it is, but there are definitely some oscillations that you see. That is the reason why this is called as a stationary wave. Otherwise, the term itself seems to be like an oxymoron. How is it possible? Stationary means that nothing should be moving. Wave means that something should be moving. So how can you have a stationary and a wave? The reason is this. The particles are moving, but there is nothing going from left-hand side to right-hand side or from right-hand side to left-hand side. That is called as a stationary wave, because when you compare it with progressive wave, you see that blue wave definitely going towards right-hand side, and this brown colored wave definitely going towards left-hand side, whereas a stationary wave, though it consists of all the particles which are oscillating, it doesn't seem to be moving either towards left or towards right. Now, in the definition of stationary waves, you might have come across a part of the sentence which says if two waves of same amplitude and same frequency are propagating in opposite directions, then stationary waves are formed. So I think it might have crossed your mind as to why should the same amplitude condition be implied? If I remove the condition of the requirement of same amplitude, then what do we get? Let us see that. I will remove this wave. I will pause the animation. Let us see wave 1 and wave 2. We will increase the amplitude of wave 1. You can clearly see that the blue wave's amplitude is increased. Let us put it at 80. And A wave's amplitude, let us keep it of half of that, 40. So these two waves, when they are propagating, it will look like this. Now, how will the resultant look like? This is how the resultant will look like. You might say that, but sir, it is almost like what we see in the previous case. True, it is almost, but not exactly. Let us hide wave 1, let us hide wave 2. Now see, does it even look like a stationary wave? You see, there is a motion. There is a motion again. And there is a motion again. Why is it, sliding towards the right-hand side, step by step? The reason is because amplitude of the wave propagating towards right-hand side is more than the amplitude of wave propagating towards left-hand side. Here you can see this blue wave's amplitude is more than the brown wave's amplitude. If you remove this, you can see that clearly. So the blue wave is carrying more energy towards right-hand side than the brown wave, which is able to carry lesser energy towards left-hand side. So the net propagation of energy or the net transfer of energy is towards right-hand side. That is the reason that it is no longer a stationary wave and it is propagating towards right-hand side. Then another condition that we come across is that the frequency has to be same. Let us see what happens if the frequency is not same. Let us bring this back to 60 and bring this one also back to 60 so that the amplitudes are same, because we can't play around with more than two variables or more than one variable at a time. Otherwise, whatever change has happened, we will not be able to figure out why this change has happened. Okay, let us bring it down to 50. That will exactly match it with that reference line. That will be easy for us to keep a track of, right? 50. But now let us increase the frequency of one of the waves. You see the blue wave's frequency has been increased and the red wave's frequency, I have kept it at 200. Let us increase it to 300, the blue wave's frequency. And now play this. Will it give rise to a stationary wave? You observe that yourself. It's looking like a big chaos, isn't it? So let me remove wave 1 and wave 2. Look at this. Can I even call it as a stationary wave? Isn't this worse than the progressive wave that I got? It had a nice amplitude, nice frequency, it was propagating, but this is a complete chaos. Right? This is also a wave, but it is no longer a simple harmonic motion. It's a combination of two motions. Therefore, we say that a stationary wave is formed when two waves of same amplitude, same frequency, propagating in opposite directions superimpose each other. In the next class, we will look at the mathematics behind it and see how all this works out.